All right, so let's talk a little more specifically about the components of the perimeter foundation. So, perimeter foundation for most single-story houses and even two-story houses is going to be 8 inches thick. Okay, the height is going to vary depending on the contours of the lot that we're building on. Okay, but the width or the thickness is, for the most part, going to be 8 inches. Okay, depending on the circumstances, and especially if we were adding a third story to the house or something like that, then maybe that's changing to 10 inches, okay? Especially if, let's say, for example, that foundation is going to be retaining dirt also. So let's say we're building against the side of a hill or something like that, and it's going to get backfilled and there's going to be a mountain pressing against the house, then that's obviously going to get much thicker, okay? But your standard run-of-the-mill single-story, two-story house is going to have an 8-inch thick perimeter foundation. Okay. We call it a perimeter foundation because it follows the outside perimeter of the house. So most houses, depending on their complexity, are just going to have the foundation poured around the perimeter, and then we're going to have these intermediate posts as part of the floor system. If, for example, you have a more complex foundation, or there's a lot of weight in the middle of the house, then maybe you're going to have another stem wall, and that's what we call this wall that follows the perimeter of the house, a stem wall. Maybe we're going to have another stem wall down the center of the house or something like that, okay? Most of the time, most of the weight is on the exterior walls, the perimeter of the house, especially, and we're going to talk more about this, but especially now that we have clear span trusses. Back when we were stick framing houses and adding ceiling joists, we had to have a bearing wall everywhere the ceiling joists were spliced. And we would typically have to splice ceiling joists if the building is wider than 20 feet, because 20 feet is generally the longest length of board that we can get. Okay, so let's just say we have a 40-foot wide house, okay, and we want to clear span that. We can get away with that with trusses. We're going to talk more about trusses, but trusses are designed so that they have two bearing points, one at one end of the house, one at the other end of the house, okay? If we're stick framing a house, if we're putting ceiling joists in, there could be intermediate bearing walls, and those need a continuous load path all the way down to the ground. And generally, that would trigger an additional stem wall, okay? And we'll talk more later about, I know people probably got really excited when I said bearing walls, because everyone's thinking, I want to tear out all the walls in my house and have an open floor plan. How do I know I'm not removing a bearing wall? Okay, the first tip is if the ceiling joists are lapping on top of that wall, then that's a bearing wall. That's supporting the weight of half the ceiling joists, okay? I'm getting a little into the woods here, so let's move on a little bit. But when you construct a perimeter foundation, again, at its most basic, you're just going to have a stem wall around the perimeter, okay? You're going to have to get materials, and that's typically going to be wood, to construct a floor system, okay? Because all we have is something around the perimeter. So these are the components of the floor system, and we have a whole lecture coming up here soon about floor framing, but this ties into the perimeter foundation. We're going to have pier blocks. Typically, those pier blocks are going to be spaced every 4 to 5 feet underneath the girder, okay? In the other, let me move forward here a little bit and I'll explain this a little bit more. The pier blocks support a post, okay? The post supports a girder, okay? I talked a little bit about this already when I was talking about old post and pier foundations, but we still utilize the same construction in the middle of the house, okay? So the girders sit on top of the posts, which sit on top of the pier blocks, which are poured on top of native soil, okay? The floor joists sit on top of the girders, And then on top of the floor joists, we're going to attach plywood subfloors, what we call it. Subfloor because it's not a finished product. It's a tongue and groove plywood. And then we'll put whatever finished floor we want on top of that, hardwood, tile, whatever we're trying to accomplish here. So depending on how far the floor joist can span, and when I say span, it means how far can they travel unsupported? How far can they just float without being supported by a girder? Okay, so there's a couple variables there. What kind of material are we using? Okay, how wide, how tall are those floor joists? Okay, a 2x12 is going to span much farther than a 2x6 because there's just so much more wood there. It's a much stronger piece of wood. Okay, so it took me a while to get here, but this row of pier blocks, we're going to have girders spaced however far these floor joists can span. Typically, it's around 10 feet. For the kind of building that we build, we're going to have girders every 10 feet under the floor joists. Okay, we'll get into a little more when we talk about floor framing, but so every 10 feet or so, we'll have a girder. Every 4, 5, 6 feet, we'll have a post that's supporting the girder that's sitting on top of a pier block. Okay. The very basic rule of thumb for girder spans is for every inch of thickness, you can have a foot of span. Okay, so if I was using 1x material, okay, I would have to support that 1x material every 12 inches. Okay, that doesn't make any sense. If I was using 2x material, I would have to support that material every 2 feet. Still doesn't make a whole lot of sense. This appears to be a 4x8 girder, so it's going to span about 8 feet. Okay, that's enough for now, but just so we know, this is going to be a part of a perimeter foundation. Okay, and there are clearances that we need to abide by, and we'll talk more about that later. Okay. The alternative is the slab foundation, and this is what we call a monolithic concrete pour. Okay, it's all one big giant piece of concrete. Okay, we're only going to form the perimeter. Okay, it's going to start out similar to the stem wall. We're going to dig footings all the way around, but we're just going to form up one side of it, and then we're going to put some gravel and plumbing and rebar and other stuff in there, and we're going to pour concrete in that entire formwork. Okay, so what ends up happening is this slab becomes the subfloor. Okay, we're not going to have pier blocks and posts and girders and floor joists. The slab is the floor, and we'll build the house directly on top of that slab. Most of the time, the slabs are going to be 4 inches thick in the middle. Okay, on the perimeter, it's going to be thicker because those are going to be the footings. The footings and the slab are all connected. It's monolithic. Okay, this footing depth is going to vary depending on when we hit clay. Okay, we don't really have, we have options, but the easiest option is to just dig until we hit clay and then pour concrete on top of that. Okay, so on the plans, they usually show this as 12 inches, but that's because we need to be 12 inches deep minimum into native soil. Okay, we're always going to be deeper than 12 inches. Okay, the width of this footing is going to vary depending on the type of soil, depending on what we learned in the soils report. Okay, we got a soils report with our lot. They said the soil is of this type of quality. You need to have footings that are a certain width to be able to support the loads. Okay, so if you have poor quality soil, one way to counteract that is to just make your footings wider, so the weight of the house is dispersed over a greater area. Okay, all right, so I think that's kind of the basics for the slab. Let's look at this picture a little bit more, I guess. Okay, so this is our subgrade. Let's pretend this is kind of like the clay down here. We've dug down to the clay. We typically don't have gravel under the footings. Typically the footings are going to be directly on top of the native soil. Okay, if we put gravel underneath the footings, we need to compact the gravel. Okay, and that's one thing that people can do if you're digging really, really deep and you don't want to put lots and lots of concrete in the footings. You can build it back up with gravel, but you have to have an engineer come out and do compaction testing on the gravel. And so usually it's kind of a wash, whether you're paying an engineer and going through all the labor of filling it with gravel and compacting it, or just going ahead and putting concrete in there. Okay, so we will have gravel on this intermediate part, but typically the gravel ends at the footing, and we'll have the footing going all the way down. Okay, then there's going to be either welded wire mesh or rebar. Excuse me. We're going to have gravel, then we're going to have a layer of plastic over that. We'll talk about that here in a little bit. And then we'll put our steel on top of that, either the welded wire mesh or rebar. Okay, and again, that steel is going to provide tensile strength. All right. Here's a picture of a mini excavator digging the footings on our house. Okay, so what would typically happen at our site after we've got it all laid out? We would have a piece of equipment, either a mini excavator or a skid steer loader, come in and scrape off all the grass. We want to get rid of all the grass. We don't want any organic matter sitting underneath our house or underneath our slab, because it's going to decompose, and then there's going to be a void underneath that concrete. And then remember what I said, if that concrete's unsupported underneath, it's going to break really easily. Okay, so what we've done, think back to our building layout lecture, is we've laid out this whole site with string lines and batter boards. We've established a 360-degree level plane, and we've set up string lines that are going to represent the outside face of our concrete. We're going to put form boards up against that string line, okay? But anyway, we've marked all that out. We've marked out where our footings are going to go. We're going to bring in a mini excavator, and we're going to dig those footings out. We're going to continue to dig, and remember, we're going to go through some topsoil, then we're going to hit kind of some milk chocolatey clay, and then we know we're getting close, and then we're going to hit our yellow clay, okay? One CR house was built on top of a gully that had been filled in over 50 years, and so we dug a little bit, and then it's like, oh, here's the old bottles layer, and then we dig a little bit more, and like, oh, here's the old car parts layer, and then we dig down again, and by this time we were 6 feet deep, and it was like, oh, here's the original grass. This was the original topsoil that got filled in, and then we dug through that, and then we finally hit clay. But it was kind of a nightmare, and the footings ended up really deep. But we just don't really have a whole lot of options other than to dig down to the native soil, okay? So we're going to dig, find some clay, make sure that we're sitting on some nice undisturbed native soil, and then we can reset all of our strings, set up our batter boards, and we'll be ready to start hanging the form boards, okay? And then the only point of constructing all these form boards is to hold the concrete in place until it's dry, okay? And then we'll take the form boards out. But we need to make sure that those form boards are level. We want them to be plumb also. We don't want the form board to be crooked, because that's just going to translate to our foundation, okay? And we're going to need to put enough stakes in it to hold it upright, and we're going to need to put diagonal stakes in, called kickers, that we'll talk about in a little bit, that are going to prevent the form boards from pushing over from the weight of the concrete, because the concrete is incredibly heavy, okay? And it wants to just wash out, okay? It's in a liquid state when we pour it, okay? And it's kind of this classic battle of, it's nice when it's really, really wet, because it's really easy to work it and it's not as much work moving it around, okay? It's harder to work it when it's dry, but it's going to stay in place better when it's dry. And the wetter it is, it's going to want to push more, okay? But either way, the concrete really wants to push against those forms. We have to build really solid forms to hold that concrete in place.